Hello guys, so now time has come when the thing which I was telling you, the most recent latest model of atom, that is quantum mechanical model of atom, I am going to discuss, proposed by Erwin Schrödinger. He gave a general equation, and with that equation the solutions give us the parameters to locate the position of electrons in orbitals rather than orbits. So let's start the quantum mechanical model of atom with the slides which I made exclusively for you guys. Let's begin.
Yes, so now we're going to discuss about quantum mechanical model of atom. It is the most latest, most recent model of atom based upon the duality of matter, means can act like a particle as well as a wave. First of all, we must know what is Heisenberg's uncertainty principle. He gave this law, with uncertainty in position and velocity. The law states that it's impossible to measure simultaneously both the position and momentum of small microscopic moving particle with accuracy. Means if you can measure position, you can't measure the momentum perfectly, or the vice versa. Means if you can measure momentum perfectly, then there will be some uncertainty in the position. And the mathematical expression for this law is given by del x into del p. It's greater or equal to h by 4 pi. Now this model of quantum mechanical thing was first developed by Erwin Schrödinger in 1926, and what he treated it as a 3D wave in the electronic field of positively charged nucleus. And he gave an expression. This is very famous expression. You all must mug up this expression: del square psi by del x square plus del square psi by del y square plus del square psi by del z square, that is with addition of 8 pi square m by h square into e minus v psi, that is equal to 0. Now this expression, what psi exactly mean, I will tell you in short time. This was the expression which has opened different parameters to locate the electron in any atom. So m is your mass of electron, capital E is your total energy, V is the potential energy, H is the Planck's constant, and psi is your wave function of the electron. Now what is the wave function? I'll come to that. So wave function, what is significance of wave function? It is actually regarded as what? Amplitude function, which is expressed in the x, y and z coordinates. Like in the previous slide, if I see, then you can see x square, y square, z square. So here I am denoting the coordinate position. So that's what is the significance of wave function psi, and the main aim was to give the solution for the probability approach. Means if I want to find which electron is present at what position. Like for example, if I have to search any boy, let learn this by example. Suppose I have to search any boy, and I know first of all the country name, then I know state name, then I know the district name, and then I will know his house number. These are the 4 parameters. In the same way, I will discuss that how you will locate the position of electron in atom with 4 parameters. We'll see that very quickly. But before that, what is the significance of psi square? Psi was it is a wave function, but what is psi square? Psi square is a probability factor. Means it describes the probability of finding the electron in that small space. So the more the value of psi square, the more is the probability that my electrons are present there in the atom. Means now in this model, it's not defined that electrons are confined to this orbit or like that. Now we are dealing with orbitals. Now we are dealing with a wave function. Now we are dealing with wave nature of matter. And the space in which we have maximum probability of finding the electron, that is what my orbital. And this equation which I just discussed in the previous slide, the solution of that equation give me the quantum numbers, which are the parameters which I was discussing, okay, quantum numbers, which will tell you about the energies of electron, the shape and orientation of the orbitals, okay, and how they are packed in any atom. So quantum number, what is quantum number? The parameters they are expressed in the terms they are called what? Quantum numbers. The first is your principal quantum number. It is the first solution of that equation. It's called in your wave equation. So what it tells the main shell in which the electron resides. Means like in the Bohr's model where I was having n is equal to 1, n is equal to 2 as a, what? The orbit number. Here I am having orbitals. Okay. So it tells the shell. And also it tells about the energy also, because the higher the number, the more will be the energy, right? And it also tells the maximum number of electrons that a shell can accommodate, that is 2n square, guys, 2n square. Like this way. In Bohr's model, I was using K, L, M, N shells, right? So principal quantum number will be 1, 2, 3 and 4, and they can accommodate how much? 2, then 2 into 2 square, then 2 into 3 square, then 2 into 4 square, so that is 2, 8, 18 and 32. Okay, this way. The second is your azimuthal quantum number. Second is your azimuthal quantum number. What it tells, it will tell you the number of subshells which is present. Like in this shell, I will be having subshells, and they are designated by S, P, D and F subshells. Okay. Also, with the knowledge of subshells, you will have the orbital angular momentum of electron, that is equal to root of L into L plus 1 h by 2 pi. Okay, for a particular value of n. And for any value of n, your L can be, L can take how many values? It can take 0 to n minus 1. So angular quantum number, that is represented by the letter L, okay, and it can vary from 0 to n minus 1. Means suppose if I say that what is the value of L I can get if I am saying that my principal quantum number is 5, then I can get 0, 1, 2, 3 and 4. Okay. Next is your magnetic quantum number. Okay. Now electron, due to its motion, okay, it is also moving, it is also revolving, everything is going inside. Now it produce magnetic field under the electric field. So that's why I have to deal with the magnetic properties of element also. So this model is well accepted because of this thing also, that it can tell us about the Stark and the Zeeman effect, which were not possible in the previous cases, if you remember. And it determines the number of preferred orientation of the electrons present in the subshell, and its value can depend upon L value. Okay, so, and it is designated by the letter small m. It can take values between minus L to plus L, including the 0. Like for example, if L is equal to 1, so my m can take minus 1, 0 and plus 1. So total values of m associated with the particular value of L is 2L plus 1. Next is very important, the spin quantum number. Okay, it tells you about the spinning direction, like just like Earth, which not only revolves around the sun but also spins about its own axis. Same is the electron. It is also revolving around the nucleus, but it's spinning about its axis as well. So it will tell you about the clockwise and the anti-clockwise direction. So by hypothetically we take plus half as your clockwise, minus half as anti-clockwise, and we designate it by this thing. The arrow, upward arrow is your plus half, the downward arrow is your minus half. And this helps to find the magnetic properties of the substances. So this is the whole story, guys. You have a shell, okay? You have a shell, and depending upon it, I can have L value, which will tell me the subshells, and I will get the M value, which will tell me what orbitals are there in that subshell, and after that I will have the spin value also. Means when I will be filling the electrons in these orbitals, I will either fill in a clockwise way or an anti-clockwise way. So that will be decided by the spin value. This you can see here. Principal L, angular momentum L, magnetic M, spin magnetic S. Okay. Spin can only take plus half or minus half value. Then we have something called nodal points and plane. What is that? It is the point where I have zero probability of finding an electron. Okay, zero probability of finding an electron. So with that, I mean that there is no electron in that space. So radial nodes and angular nodes are the types. The former is the radial one, which is concerned with the distance from nucleus. Okay, and the latter is concerned with the direction. If you were asked in any exam about the radial nodes and angular nodes, the number of radial nodes, that is equal to n minus L minus 1. Number of angular nodes is L. So what is the total number of nodes? You just add these two, you will get n minus 1. Okay. The total number of nodes means where I don't have any electron in that atomic space. So nodal planes, they are planes which have zero probability of finding the electron. And number of such planes is also equal to L. That is the angular nodes. Okay, concerned with the direction. Now, these all orbitals like S, P, D, F, they have different shapes. So let's see each one. Orbital, as you already know, it is the space around the nucleus which has maximum probability that I can find my electron there. Okay, and the shape could give the shape of orbital, shape of that region, the electron cloud. So for S orbital, what will be my value of L? It will be L is equal to 0. So these orbitals are spherical and symmetrical about the nucleus, and the probability is maximum because they are very close to the nucleus and keeps on decreasing as the distance from the nucleus increases. That means if you go further from the nucleus, the probability of finding that electron in the S orbital will be lost. Okay, and there is a vacant space between two successive S orbitals. Okay, which I will tell you that what that space actually composed of, which is known as radial node. And for 1s there will be no radial node. Okay, because L is equal to 0, right guys? This is starting from the nucleus. So this is the dramatical view of the S orbital. This is 1s, this is 2s. There is no node here. Here you can see a node. Here you can see two nodes, right? In this way. This is the contour probability of S orbital. And this is the radial probability, guys. Means electron probability versus the distance. For 1s you can see, electron probability is maximum because it is the closest orbital to the nucleus. And if I say for 2s, then it is somewhat less. Then 3s it is somewhat less. They are getting some peaks, right? According to the number of nodes there. Next is p orbital, where L value can take 1. So the probability of finding the p orbital is maximum in the two lobes, which are on the opposite sides of the nucleus. Okay, that's why they are also known as what? Dumbbell shape for the p orbitals. For p orbitals, my L value will be equal to 1 and M can take these three values. So p orbital in total, how many will have the orientation? I will have 3 different orientation in the x, y and z axis. That's why here it's written px, py and pz. And they are not spherically symmetric, okay, because they have the direction character. So the two lobes, they are separated by a nodal plane, where I have zero probability to find the electron. And they belong to a particular energy level, okay, and that's why they have degenerate energy, means equal type of energy, px, py and pz. The shape is like this, guys, the double dumbbell shape. This is one bell, this is one bell, these are two dumbbells, and you have a nodal plane, okay. Similarly here also, similarly here also. So here the direction is in x, this is in y, this is in z. So three p orbitals, they are aligned according to along the perpendicular axis. Next comes d orbitals, for which my L value will have the value 2. So L is equal to 2, that means I can have 5 orbitals here, okay, 5 orbitals here. So they have relatively complex geometry actually, and out of these, the 3 dxy, dyz, dz, they are between the axis, and the other two lie along their axis, means z square will be in the z axis only and z square y square will be in the z square y square, the whole space only. This is a shape, guys, okay, of d orbitals. You can see the 3 dxy means xy plane, 3 dx means xz plane, and you can see even the nodal plane, guys, okay. These are the nodal planes, means there I don't have any electron space there. Similarly for the dyz case, for 3z, dz square means what? I have on the z axis only. This is, the rest is your nodal plane. Here for x square, y square, I have x and y axis. So this is all about the shape of orbitals and the quantum mechanical model of atom, which is considered as the electronic cloud space of electron around the nucleus, and which understand us to more get into the structure of atom, what atom is actually composed of. Can we treat electron as only a particle or a wave? But we saw that we can treat them as both the things, okay. We can treat them as a particle also and a wave also.
So guys, here in quantum mechanical model of atom, I told you about the wave particle duality of nature, of matter, how it came in the atomic case as well. Like here we use a concept of orbitals, not orbits, and I also told you about various orbitals based upon the quantum numbers which was proposed by Schrödinger, which are the solutions of that general equation. Also we saw the shapes of different orbitals like s orbital, p orbital, d orbital and f orbital. Now these are the orbitals. In these orbitals I am going to fill my electron, and that is called what? Electronic configuration, which is the basis of periodic table. So that electronic configuration I am going to discuss in the next part, so stay tuned with me for that.